Bismillah Rahman Rahim. Consider a Gaussian random variable x with the mu x is equal to r and sigma x is equal to r over 2. Find the probability that part A, probability that x is less than or equal to 2r. Part 2, probability that x is greater than 3r. Consider r is equal to 100. So given that r is equal to 100, so the mean mu x is equal to r is equal to 100, and the standard deviation sigma x is equal to r by 2, and that is 100 over 2, and that is 50. Now the part A, we need to find the probability that x is less than or equal to 2r. So it means that r is equal to 100, so we need to find probability that x is less than or equal to uh, 200. So x is a Gaussian random variable, right? So we can convert this to standard normal variable and then find the probability. So we know that the, the probability that x is less than or equal to a value x is given by the value of the standard normal CDF, which is designated as capital Phi at z, where z is equal to x minus mu x divided by sigma x. So in this case, x, the value x is 200, right? So for this, we can find the value of the z, and then from the standard normal CDF, we can compute the probability, given probability. So in this case, z is equal to, the value of x is 200. So 200 minus the mean value is 100 divided by the standard deviation, which is 50. So this comes out to be 100 divided by 50, and z is equal to 2 in this case, right? So the probability that x is less than or equal to 2r or 200 is equal to the value of the standard normal CDF at 2. Z is equal to 2 here, right? So we can just look up the value of the standard normal CDF at this point in the table, and then we can have this probability. So let's look at the standard normals, the table of the standard normal distribution. If you look at the table, this is the table for the standard normal function, standard normal distribution, and we have this is 1.9 and this is 2, right? So at 2, the value of the standard normal is 0.97725. 0.97725. So this is 0.97725, the probability that x is less than or equal to 200, right? So the key relationship to understand here is this: the probability that x is less than or equal to value x, the random variable x is less than or equal to value x, is equal to the value of the standard normal CDF at point z, where z is given by this formula here, where x is this value here. So this is 200 minus 100 divided by 50, and this gives us 2. And then according to this formula, the probability that x is less than or equal to 200 is equal to the value of the standard normal CDF at 2. So that we calculate, that we have seen from the table, that it is equal to this value. So this solves us for the part 1, and now the part 2, probability that x is equal to 3r. Now r is equal to 100, so that means this is equal to probability that x is greater than 300. Now note that this is greater than here. It was a smaller than here, over here. So when we're given this, need to compute this probability, then we have similar formula like this: probability that x, random variable x, is greater than the value x is given by the standard normal complementary function, the value of the standard normal complementary function at c, right? And which is equal to 1 minus phi z, right? Or we can write this also like this: x is equal to 1 minus probability that x is less than, sorry, 1 minus probability that x is less than or equal to x, right? Yes, right. And then that is again equal to, according to this, is this is equal to 1 minus phi z. So this is 1 minus phi z, probability that x is greater than equal to x, and that is equal to basically q z. And again, from this formula, we can also write phi z is equal to 1 minus qz. Uh, the other way around, we can also write it like this: phi z is equal to 1 minus qz. This is also true, right? So we need to use these relations to compute the probability like this. So in this case, uh, this x is greater than 300, right? So the value x is 300. So in this case, z is equal to, according to this formula, uh, this is 300 minus mu x, which is 100, divided by the standard deviation, which is 50. So this is 300 minus 200, 100 is 200 divided by 50. So z is equal to 4 here. So according to this formula, probability that x is greater than 300 is equal to the value of the standard normal complementary function at at 4, right? Or we can write that this is equal to 1 minus the standard normal function at 4, right? So we can look up these values from the table, and then we can compute the probability. So let's look at the table of the standard normal complementary function. So if you look at the table, the this is value 4 here. So this is 3.17 into 10 power minus 5. So this is the value for 3.17 into 10 power minus 5. So this gives us the required probability that x is greater than 4, greater than 300. So this gives us the required probability. See, the other way around is to find the value of the standard uh, uh, normal function at 4, and then perform this subtraction to compute this probability. So in some tables, this large value of the standard normal function is not provided. It's probably not provided. So for example, here in this table, in this book, the value of the standard normal function only till 2.99 is available, right? And the further values are not available. For the further values, we need to use this complementary function. We can then use this relationship, these relationships, either this one. If we can find the value of the function from Q table, we can, and to find the value of phi z, we can use this relationship. Or if we can use the value of the phi from the standard normal function and to convert it to qz, we can use this relationship. So in this case, we have found the value from the standard normal complementary function, the value at 4, and we have directly found the probability that x is greater than 300. But the point to remember is that the probability that x is less than or equal to x is given by the value of the standard normal function at z. However, when we need to find the probability that x is greater than, for example, x, then we need to find the probability this way, the value of the standard normal complementary function at z, right? So this relationship, in this case, when x is less than or equal to x, we need to find this probability. We use this function, standard normal function, and when the probability that x is greater than x, we need to use the standard normal complementary function. So this concludes the solution to the given problem.